Hello, hi everyone. Welcome to another solution from the Leetcode problem section. And today we are going to solve another problem on the similar topic, array and hash table. The difficulty level is easy, and the problem here is problem number 1. Okay, so we are doing it a bit late, but yeah, let's try this. Okay, the problem description is as: given an array of integer nums and an integer target, return indices of two numbers such that they add up to target. Alright, you may assume that each input have exactly one solution. Alright, that's helpful. And you may not use the same element twice. You can return the answer in any order. Okay. So let's take an example here: 2, 7, 11, 15, and the target is 9. Yeah, we can see that 2 and 7 adds up to 9, and the indices are 0 and 1, so that's the answer, right? Okay, good. Here we also know that only one valid answer exists. That means there are no 0 or 2 valid answers. Okay, and a follow-up question is, can you come up with the algorithm that is less than big O of n square time complexity? So yeah, let's dig deep into the coding. Okay, how would you approach this problem if it was a brute force solution? So we'll simply say that n is the length of numbers for I in range n, for j in range I plus 1 to n, because we are not allowed to use the same element twice. So for example, here in example number 2, 3 and 3 could add up to 6, but once we have taken 3, we cannot take 3, we should take other number that's like after 3. Okay, so we'll try each and every number with every other number and see if nums, why is it complaining, if nums of I plus nums of j equals to target, then we'll simply return I comma j. Since we are guaranteed to find an answer, that means somewhere down the line we will have an I and a j that sums up to target. And let's try this. Okay, it's taking quite long. It works. Let's try the example test cases. Yep, it works fine, but the problem is this is big O of n, this is big O of n minus 1 obviously, and this is a simple comparison, so we can consider this as constant time complexity, which gives us the time complexity of order of n square. And we have a challenge here that we have to come up with a solution that is less than order of n square. So can that be done? So if you look carefully, we are not utilizing any memory here other than this single variable which stores a length of numbers. What we can do instead is we can use some kind of memory to store some values that we have already seen while computing the number. Okay, and in the process, if we check that it sums up to target, then we may do it, right? So let's say there is something called lookup dictionary, which stores key as the number and its value as the index, right? So for I comma num in enumerate nums, what we want to do is we want to calculate the difference, and difference will be target minus number. Okay, and we want to check if difference is already in the lookup. If it's already in the lookup, we simply want to return what? Lookup the difference comma I, right? I'll do a dry run and then explain how it works. Okay, otherwise what you're gonna do is we will simply store the number as its key and the index as its value. Alright, so in this example 2 7 11 15 and the target being 9, what happens is, first for the index 0 and value 2, what happens, difference is calculated. Target is 9, 9 minus 2 is 7. Now we'll check if 7 is in the lookup, but since lookup is initially empty, there's nothing, we will not be executing this line. Instead what we'll do is we'll store the 2 with its particular position that we already have, right? In the next iteration for index 1 and the value 7, what happens, we will calculate the difference again, that's target minus number, 9 minus 7, which will be difference with 2. If 2 is already in the lookup, yes, if you remember in the previous iteration we stored 2 and its index, yes, we have already 2 stored in the lookup, so we'll simply return the index of 2 and the current index, because together they add up to the target, right? So that's the basic idea. Like, keep on moving forward and keep on checking if the difference is already in the lookup, because yes, the difference and the number that we are currently using, that we are currently in the iteration, will sum up to target, right? So at some point we will find that we have already encountered the difference in the past and use that logic to find the indices. Here difference in lookup is an constant time, so we have reduced the time complexity from big O of n square to big O of n. Okay, let's see if it works. Yes, it does, and this is all of our test cases. Okay, obviously I don't have premium, I don't know why did I click that. Alright, let's try to submit this and see how it works. As you see, I have already tried and tested this, and we can see that it's pretty efficient. We have an additional space requirement here because we wanted to decrease the time it takes. Okay, so there is a trade-off between time and space here. अब नेपालीमा एक्सप्लेन गरौँ है त। नेपालीमा भन्दाखेरि टु सम प्रब्लम हामी आज लिएर आएको छौँ। यो प्रब्लम चाहिँ इजी क्याटेगोरीमा छ, तर यसको फलोअप क्वेसन गर्दाखेरि चाहिँ खासै इजी जस्तो पनि फिल नहोला, किनभने चाहिँ इट रिक्वायर्स सम अलिकति दिमाग ख्याउनै पर्छ है त। सो टु सम प्रब्लम के छ भने चाहिँ नम्बर्स भनेर एउटा आएर छ, त्यसबाट चाहिँ दुईवटा नम्बर हामीले चुज गर्नुपर्ने, त्यो दुईवटा नम्बर चुज गरेपछि चाहिँ त्यसलाई जोड्यो भने टार्गेटसँग बराबर हुन्छ, अनि त्यो दुईवटा नम्बर जुन चुज गरेको छ हामीले त्यसको इन्डाइसेसहरू चाहिँ रिटर्न गर्नुपर्ने। अब यो प्रब्लम स्टेटमेन्टले एउटा अझै कुरा के भन्छ भने चाहिँ एउटा मात्र सोल्युसन एक्जिस्ट गर्छ है भनेर, भन्नाले प्रब्लम सल्युसन छैन अथवा सल्युसन एउटाभन्दा धेरै छ भनेर पनि छैन है। फर इक्जाम्पल चाहिँ 2 7 11 15 मा चाहिँ र 9 टार्गेट हुँदाखेरि 2 र 7 चाहिँ 9, 2 र 7लाई जोड्दाखेरि 9 हुन्छ, 2 र 7 को चाहिँ रेस्पेक्टिभ इन्डेक्सहरू चाहिँ 0 र 1 छ, सो हामीले चाहिँ 0 1 आन्सर पायौँ। अब यसलाई ब्रुट फोर्स अप्रोच अथवा सुरुमा सोच्दाखेरि चाहिँ दुईवटा फोर लुप लाग्यो, एउटा फोर लुप चाहिँ 0 देखि n सम्म चल्यो, अर्को फोर लुप चाहिँ लाइक आई प्लस 1 देखि n सम्म जान्छ। त्यसले गर्दा के हुन्छ भने चाहिँ अर्डर अफ n स्क्वायर हुन जान्छ हैन। तर त्यति बेला चाहिँ हामीले स्पेस चाहिँ के कन्ज्युम गरे हुँदैनौँ, स्पेस कम्प्लेक्सिटी हाम्रो लाइक कन्स्ट्यान्ट हुन्छ। अब हाम्रो फलोअप क्वेसन के छ भने चाहिँ कुनै एउटा सोल्युसन अल्गोरिदम बनाउन मिल्छ जसले चाहिँ अर्डर अफ एन स्क्वायर टाइम कम्प्लेक्सिटी भन्दा बिग अफ एन स्क्वायर भन्दा थोरै लिन सक्छ भनेर। अनि अलिअलि हिन्ट पनि छ, तर हिन्ट नहेरिकन गर्न मिल्छ कि भनेर सोचेर यसो हेर्दाखेरि चाहिँ के गर्न मिल्छ भनेपछि हामीले चाहिँ टार्गेट माइनस नम्बर जुन करेन्ट नम्बर युज गरिरहेको छौँ नि, लुपमा छौँ नि, त्यो डिफ्रेन्स निकाल्ने है। अनि त्यो डिफ्रेन्स चाहिँ लुपमा लुकअप भनेर चाहिँ एउटा डिक्सनरी मेन्टेन गर्ने। त्यो डिक्सनरीमा चाहिँ खास के हुन्छ भनेपछि जुन हामीले चाहिँ नम्बर हेरिसकेका छौँ र त्यसको इन्डेक्स, त्यो दुइटालाई चाहिँ की भ्यालु पेयर बनाएर चाहिँ राख्ने है त। यदि त्यो डिफ्रेन्स पहिलेदेखि लुकअपमा छ भनेपछि मैले अहिले आइट्रेट गरेर आएको नम्बर र डिफ्रेन्सलाई जोड्यो भने त टार्गेट हुनुपर्ने हो। सो त्यति बेला चाहिँ हामी के गर्न मिल्छ भनेपछि त्यो डिफ्रेन्सको लुकअप टेबलमा गएर इन्डेक्स खोज्ने, त्यो र अहिलेको करेन्ट इन्डेक्स चाहिँ रिटर्न गरिदिने, किनभने चाहिँ त्यही दुइटा जोडेर चाहिँ हाम्रो टार्गेट हुन्छ। नभए चाहिँ के गर्ने हामी लुकअपमा त्यो पर्टिकुलर नम्बर र त्यसको इन्डेक्स चाहिँ राखिरहने। सो 2, 7, 11, 15लाई हेर्दाखेरि के हुन्छ भनेपछि पहिलोमा फर्स्ट आइट्रेसनको बेलामा चाहिँ लुप चल्दाखेरि पहिलोपल्ट 2 जान्छ, अनि टार्गेट चाहिँ 9 छ, 9 - 2 गर्दाखेरि 7 हुन्छ। 7 लुकअप टेबलमा छैन किनभने चाहिँ इनिसियली एम्प्टी छ होइन। त्यही भएर चाहिँ हामी के गर्छौँ, यो लाइन चाहिँ एक्जिक्युट हुँदैन। अनि यता लुकअपमा चाहिँ 2 एज अ की र त्यसको इन्डेक्स 0 चाहिँ स्टोर भएर बस्छ। अर्कोपल्ट जाँदाखेरि चाहिँ के हुन्छ भने चाहिँ 7 जान्छ। 7 जाँदाखेरि चाहिँ 9 - 7 हुन्छ, 2 भनेर डिफ्रेन्स आउँछ। अनि 2 त हामीले पछि पहिलो आइट्रेसनमा चाहिँ सेभ गरेका थियौँ। सो हामीले के थाहा पायौँ त, 7 चाहिँ अहिलेको करेन्ट छ र 2 हामीले पहिल्यै स्टोर गरिसकेका छौँ भनेपछि झ्याप्प गएर त्यो 2लाई चाहिँ झिक्ने, अनि 2 को इन्डेक्सलाई झिक्ने, अनि अहिलेको 7 को इन्डेक्स झिक्यो, अनि त्यसलाई चाहिँ रिटर्न गराइदियो। अनि यो सब्मिट गर्दाखेरि चाहिँ हाम्रो लाइक निकै नै एफिसियन्ट थियो। यदि तपाईँहरूले चाहिँ योभन्दा राम्रो सोल्युसन भेटाउनु भएको छ र यो कोडमा कुनै इम्प्रुभमेन्ट देख्न सक्नुहुन्छ भनेपछि सजेस्ट गर्नु होला, कमेन्ट गर्नु होला। Please comment if there are any improvements that you see can be made in this code. Please do that, and if you like it, please if it is helpful, please like the video, also share it among your friends, and subscribe the channel for further updates on the Leetcode questions, and see you in the next one. Thank you so much.